Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about graphing quadratic equations. So if you recall, that's pretty much everything that is covered in this unit is all about quadratic equations, okay? And that quadratic equation is right there. So I've got ax squared plus bx plus c. All right, that's a quadratic form equation. All right, as far as graphing quadratic equations, when you graph it, okay, it will look like this kind of U/V shape, right? But it's not a V, it's got curve to it. It's definitely a U. And we call this a parabola, okay, so that shape. So, and as I've kind of noted down here, and we'll talk about these terms in a minute, but parabolas could be opening up or they could be opening down, okay, so something to think about. Now, something interesting about whether or not it faces up or opens down is that's all based on your A value. Okay, so if your A value is positive, it's going to be a smile. So we kind of think about it like if A is positive, right, then it smiles, right? I started writing positive and smiles at the same time. Positive. Okay, so it's a smiling graph. It's happy, it's positive. But if A is negative, then it's going to be a negative graph. Okay, it's going to be a frown. It's going to be unhappy, sad. So if A is positive, it'll be a happy graph. If A is negative, it'll be a sad graph. Okay, again, this is the parabola. A couple other terms we need to point out here. I know there's a lot going on this picture, but for starters, this down here, this lowest point, this is a graph that's opening up, okay? So in this case, it's the lowest point on that parabola. We call that the vertex, okay? As far as these 2 points right here, so that's where our parabola crosses the x-axis. We call those roots, okay? And when they say roots, what they mean is the x-intercepts. So you could have one. You could, if your parabola like just barely touch the x-axis and then lift it off, we'll see something like that. You could have two, like here, where it very clearly hits at 2 places. Or you could have none, because it could be that your graph doesn't even touch the x-axis and it just goes on from there. So as far as roots, could have 1, 2, or none. All right, but those are our x-intercepts. Next thing I want to point out is this blue line. This is called our axis of symmetry, and a lot of times it's shortened by AOS. And sometimes people will even shorten it further by just calling it X. But we, in our classes, always try to say axis of symmetry or AOS, so we don't confuse anybody. But the formula to find this axis, so this axis is what divides, it mirrors the parabola. So the parabola will be the exact same on this side, and it'll be the, let me say that again, sorry JJ. So the parabola will be mirrored on either side of that axis of symmetry. And we'll see that kind of mirrored effect in a minute when we do our tables. Now, there's a specific formula to find the axis of symmetry. Okay, it's x equals, or axis of symmetry equals, negative b over 2a. So remember, this is our a value, that's our b value. Okay, so we'll play with that more in a second. That is a formula that you do need to have memorized. It's just a little one, but you need to go ahead and memorize that. So just to touch down here again, if it is a parabola that opens up, so it's a positive, then we would say the vertex, so right here would be the vertex, right? And we would call it a minimum. So you could use those two terms interchangeably. If it's a positive graph opening up, positive parabola, then we would call it a minimum. You could use vertex or minimum, okay? But if it's a graph that's got a negative a and it's opening down, right? So it's kind of like a sad graph, then the vertex would be up here. and we would call it a maximum. So in that case, you could use these two terms interchangeably. Sometimes they'll call it a vertex, sometimes they'll call it the maximum. Okay, so it just means that we would have a maximum point on a graph versus a minimum point on a graph. Low versus high. Okay? So let's put some of this, all of this, into action. So I've got an equation that they've given me. Now that is a quadratic equation, or it's actually an expression, if we're being technical about it. So I'm going to make it an equation. Should have done that. So if you recall from the previous unit, we talked about f of x, and we said that f of x is interchangeable with y. When we're talking about graphing functions, we use f of x. Don't get too hung up in that. Just see f of x, you think y. Y equals, f of x equals, okay? And then I've got my equation. So, a couple things I need to know. I need to be able to say the axis of symmetry. I need to be able to tell you the vertex. I need to be able to say whether it's a minimum or maximum. So does it open up or open down? And what are the roots? Now, what I love about this lesson is so much of this can be found out on the calculator. So let's start with just the axis of symmetry. This is a very calculator-heavy lesson. I can find axis of symmetry using this formula. So the AOS, axis of symmetry, equals negative b divided by 2 times a. So my a value here would be 2, all right? And my b value would be negative 4. Now we have to be really careful because there's a negative in the formula, okay? So we can't just say, oh, there's a negative there, negative there. They both count, right? I only have to write one. No, you gotta write the negative in the formula, and then since this is a negative 4, then you have to write the negative 4. Okay, so don't let that get too confusing. Divided by 2 times a, and we said our a value was 2. So 2 times a. All right, so negative times a negative is a positive 4. 2 times 2 is positive 4. And 4 divided by 4 reduces to just 1. Once you get that final number, that is your axis of symmetry. Now, it's kind of like that's our foundational point for our table. So we're going to put that 1, it's an x value, okay? Remember we said it's x equals, so it's an x value. We're going to put it in the center of the table. And then I want to build my other x values around that. So I'm going to do 2 below 1 and 2 above 1. So it would go 1, 0, negative 1, right? That would be 2 points below. And then I want to do 2 points above. So 1, 2, 3. Okay, now, you could take your time, and it would take a long time, to sub in each value for x into the equation and solve to see what it would be. That's very time consuming. Let's take a shortcut, okay? I love this. So bring out your calculator, your graphing calculator. All right, and we need to go to our y equals function. All right, and we need to type in that equation. So it's y equals, f of x equals 2x squared minus 4x minus 3. All right, now this is very important. You need to have on your second line a 0. I know it seems very small. If you do not have that 0 there, this stuff that we try to do in a minute is not going to work. And you're going to get so confused, and I know because I've done it 50 million times. Why is this not working? And then I think, oh, I did not put that 0 in, okay? So you have to have the 0 in. So then, let's go ahead and graph this. Let's just see what it looks like. Okay, so there's my parabola, and I can go ahead and say whether it's a minimum or maximum, right? I can clearly see that my lowest point and it is down here, and it opens up. Now, I could have known that just based on my a value being positive, that it would be a smiley face graph anyway, but, you know, I always just like to see it and then make my assessment. So we would call this a minimum. It's in the lowest part. The vertex would be at the lowest part of the graph, so it's a minimum. All right, now we've seen what it looks like. Let's look at the table of values. So go to second graph. That takes us to the table. Now, for some reason, it started me at 7. Let's see what happens. Remember, I chose my center value as 1, okay? And then I said we were going to build around that. And I chose that 1 because I found it here. That was my axis of symmetry right there. So when the axis of symmetry is 1, I see that the y is -5. And when the x is 0, the y is -3. And when the x is -1, the y is +3. Moving down, so when the x is 2, y is -3. And when the x is 3, y is +3. Okay, now I'm just going to move this over for a second. Hopefully you'll notice a pattern here. This is a mirrored image, okay? So it's like -5 is your center point. So hopefully you'll notice this pattern that has formed here. It's kind of like -5 is the center, and then these two are the same, and these two are the same, okay? So it's like a mirrored image. This is mirrored to this, okay? That's what you want to see. If you do not see a mirrored image here and a pattern there, you've done something wrong. So go back and check maybe your axis of symmetry or something. Something's not right. Okay, so in order to find my vertex, there's 2 different ways I could do it. One is literally just by looking at this, okay? Your axis of symmetry value is your x value of your vertex. So this was kind of the point that we plotted, right? This whole thing, that point, 1, -5, that is your vertex. Okay, so one way to find it is literally just to look at the table. Find your axis of symmetry that we used to build this whole table, and then whatever its partner is, that's the vertex. Okay, so that's one way. There is another way, and that way, I'm going to pull my calculator back over here. All right, now we left off, we were here at the table. Let's graph this. We already graphed it, we saw what it looked like. I want to know what that vertex is. There's a way to do it. So you would hit second trace, and we got to think, are we finding a minimum or a maximum? We said it was a minimum, and minimum is number 3 right there. Okay, so I want to take my little, I call this the spaceship, okay? I want to beep, beep, beep it all the way to the very bottom of the graph, okay? Now you'll notice this says left bound. So what I do is I move left. I always do 3 spaces. So I go 1, 2, 3. And I lock it in by hitting enter. So now it'll say right bound. I need to go back to center. 1, 2, 3. And now I want to move right 3 spaces. 1, 2, 3. Lock that in. And you'll notice when you do the lock, these little like sideways triangles show up. That one's kind of hard to see because of the line, but those little triangles will show up. That way you know you're locking them in. And then it says guess. Yeah, we want to guess. What is the vertex? Now, it'll usually give you a long decimal, okay? But we can clearly see if we round that decimal to the nearest whole number, that would be 1, and y is -5. Isn't that what we got for our vertex? 1 and -5. Okay? So, those are 2 different ways you can find it. Personally, I think it's easiest just to kind of look at the table and see what was my axis of symmetry and what is its partner. But now you know how to find it on the calculator too. All right, the last part that I need to know and be able to know is the roots. This, I have to use my calculator for this because sometimes the roots are really clear to see and sometimes they are not. Okay, so we're working under the assumption that they are not. Sometimes they're fractions. So I left off here, I just found my vertex. So I'm going to clear that. All right, it keeps me on the graph, but it just clears what I was doing. Now in order to find those 2 roots, so I see I've got 1 there and 1 there. Okay, I'm going to hit second trace again. I'm going to go to intersect 5. We've used this function before when we were doing systems of equations. And it's essentially when you want to find the intersection between two things. All right, so it says first curve. We want to move that little spaceship over to my first intersection right there. And you just approximately as close as you can get to it. Now I hit enter 3 times. 1, 2, 3. It tells me the intersection. Now, I do not want to write that long decimal. Okay, I'm going to use some just reasoning, and I'm going to round it. It didn't specify, so I'm going to round it just to the nearest hundredth. That's always a safe choice. All right, so my x values would be, and I'll use my brace, okay, because I'm going to have this one, but in a minute we're going to find out this one too. So right now I'm just talking about the first one. All right, so negative point, that's 581, so I'll just round it to 0.58. Okay, that is my first root. So now I want to clear that out. Stays on the graph, it just clears out what I was doing. I want to do the same thing again, but this time I want to find that intersection. So second trace, all the way down to intersect. And there's my spaceship. It'll usually show up right where it just was. I want to beep, 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 beep it over to the other side. And again, you just want to get at approximate really right at that intersection. Hit enter 3 times. All right, now it tells me the intersection again. It's a long decimal. I'm going to round to the nearest hundredth. So my other x would be positive 2.58. End brace. Okay, so those are the things that you need to be able to find when given a quadratic equation. Now, the other thing that they are going to ask you to do, which I did not do in this video, but I don't think you guys should have any problem doing it. And that is taking each of these values, right? Because these are points. These are points on the graph. This is 1 point, 2 point, 3 point, 4 point, 5 points. They are going to expect you to take these 5 points and actually plot them on a graph. Now, what's nice is you've got your calculator, so you can estimate, okay, I know it should look about like this. Now, your teachers are going to be looking for the exact points that it crosses the x-axis here and here, and the exact point that it crosses the y-axis. So I see a lot of students trying to just, skirt by, and they just do a U-shape. You got to be really specific. You got to plot the points and connect using your U. But you have this as kind of like a blueprint to make sure you're doing good. Okay, but so you guys know how to plot points. You would just need to plot those 5 points and connect them. No problems. All right, let's look at a couple more examples. All right, a few more examples. So here are some more equations, and again, I need to be able to fill out a table and state what each of these things are using the calculator to help, which is very helpful. Okay, so first thing that I need to find is my axis of symmetry. So if you recall on the last page we showed you the formula, and the formula was negative b over 2 times a. Okay, remember this is your a value, the coefficient there, and this is your b value. So we want the negative b value. Now 6 is already negative, so I can't just assume that one would cover both, okay? You've got to show negative 6. All right, divided by 2 times a. A is 1. Okay, let's simplify this. Negative 1 times negative 6 would just be positive 6. 2 times 1 is 2. 6 divided by 2 is 3. Okay, so there's my axis of symmetry. It's 3. So that's going to be my center point in my x values, and I'm going to build my table around that. So I would want to have 2 values right below 3. So I would do 3, 2, 1, and then 2 values right above 3. So 3, 4, 5. Okay, I'm going to bring over my calculator. I'm going to go to my y equals function, and I'm going to type in this equation, x squared minus 6x plus 9. Now you have to have that 0 on the second y equals sign. Don't forget that. Okay, let's go ahead and graph it. Let's just see what this looks like. Okay, so this one looks definitely a little different from the other one. It still opens up. Okay, so it's still going to be a minimum. It's really kind of hard to tell. Does it just barely touch the x-axis, or does it have 2 points that it hits the x-axis? Well, we're going to find that out in a minute when we get down here to do roots, but it's definitely a little different looking. So let's go to our table, second graph, and let's plot in these values. So I want to know, what is y when x is 3? When x is 3, y is 0. Alright, when x is 2, y is 1. When x is 1, y is 4. Okay, let's move down. So when x is 4, y is 1. And when x is 5, y is 4. Okay, so hopefully you see that pattern there. You can kind of think of it like a rainbow pattern, because those two should be the exact same. Okay, you know you've done your table right if you've got your mirrored image. And we could go through all the headache of finding the vertex on the calculator. Personally, I think it's just a little easier to know that it is the axis of symmetry and then whatever its partner is. So the vertex is 3, 0. So the last thing I need to be able to do is to tell the roots. So this I have to use the calculator for that. So I'm going to bring it back. I'm at my tables right now. I'm going to go back to my graph. So remember, I hit second trace. I want to know the intersect. Okay, now your spaceship, that time it showed up way up there. Sometimes it'll show up off screen. I'm not really sure the reasoning behind where it shows up most of the time, but whatever. I want to put it to where it looks like it starts to touch that x-axis. Alright, I'm going to hit enter 1, 2, 3 times. Alright, now it's going to give you a long decimal. You need to do some rounding. So my x here is 2.9 repeating. So let's round that up to 3. Alright, so my roots here will be x equals, got a brace, and I know I've got 3. Let's see, let me try to intersect again. I'm going to do it right over here. It could be just a hair different, okay? Or it could also be 3. Let's see. Alright, so I'm going to clear this, do second trace again, intersect. Now, if you're noticing, if you're following along with this, and you're like, oh, mine doesn't look like hers, mine doesn't say first curve, and it doesn't let me move the spaceship around, that means that back here at your y equals, you don't have a 0 on that second line. Okay, I've made that mistake many a time. So just, if that's the problem you're having right now, that's probably what's wrong. Okay, so I'm going to move my spaceship to where it looks like it just starts to touch the x-axis over here. I'm going to hit enter 3 times. 1, 2, 3. And see, it says the intersection is 2.9 repeating again. So we're going to round that up to 3, and that tells me that this parabola only has one root, and that's 3. Okay, so it only, even though it was hard to tell, it just barely kisses that x-axis and then moves on its way up. There's no 2 intersections there. So that's kind of a different problem. Now, just so you're aware, we don't do an example where this happens, but just so you're aware, if your parabola did not even touch the x-axis, so let's say it like looped up, or let's say that it looped down and it started to curve before it even got down here to the x-axis, and it asked you for the roots, you would put none. You would just write none. It doesn't hit the x-axis at all, you're not going to have any roots. So, just so you know. Okay, let's look at this example. I need to know my axis of symmetry, vertex, min or max, and my roots. So let's go ahead and figure out the axis of symmetry. We're going to use that formula, negative b over 2a. My b this time is positive 2, so it's just going to be a negative 2 over 2 times a, and a is just 1. So I end up with a negative 2 divided by 2 times 1 is 2, which would just give me negative 1. So there's my axis of symmetry. That's what I'm going to build my table off of. Okay, so I want to pick 2 points below negative 1 and 2 points above negative 1. So it will be negative 1, negative 2, negative 3, and then negative 1, 0, 1. Okay, so let's bring our calculator over. Let's go to y equals, type our equation in, x squared plus 2x minus 3. Make sure you go down to your second line and input your 0. So important. It will cause you tons of problems if you don't. All right, and let's graph it and see how this looks. And yet again, we have a smiling graph, okay? So yet again, it is a minimum. They're not all going to be minimum, okay? If it was maximum, it would look like an upside down U. So didn't have any in this video. That's okay. And I can clearly see too that I'm going to have 2 roots. I'm going to have 2 x intercepts. All right, so let's look at the graph, the table. So second table, and I want to fill in my table over here. So let me go to my axis of symmetry, negative 1. So I see when x is negative 1, y is negative 4. When x is negative 2, y is negative 3. And when x is negative 3, y is 0. So below, where x is 0, y is negative 3. And when x is 1, y is 0. So we do have that rainbow pattern where this matches and that matches, so I know we're doing a good job. All right, my vertex is going to be the center point, so the axis of symmetry, negative 1, and whatever its partner is, negative 4. And I already said that it was a minimum, so I need to be able to say the roots. So I'm going to bring my calculator back over. I'm going to look at the graph. Okay, so I hit second trace, go to intersect, 5. There's my spaceship. I want to beep, 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 beep it over to that first intersection. Just get it right approximately where it is. Hit enter 1, 2, 3 times. Okay, so I see it intersects at negative 3. So x equals negative 3. Now I know I'm going to have another one over here, so I'm going to go ahead and put my comma in. So I'm going to clear that, do second trace again, intersect 5, and beep, 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 my spaceship all the way over to the other side, right there. 1, 2, 3, enter 3 times. And I see that intersects the x-axis at 1. All right. So again, you will have to be able to graph these on your own, but they will give you a graph to do it. It's literally just a matter of plotting points and connecting the dots. All right, this has been Miss Math Tutorials.